Can your woven wire mesh take the pressure? And what happens when there's too little pressure? Stick around and I'll tell you everything you need to know. Hey there, what's up? My name's Andrew Kotlar, and woven wire mesh is widely considered one of the most versatile screening materials on the market, and understanding the pressure loads within your system will allow you to implement a mesh that delivers optimal filtration forever. Not forever, but for long periods of time. So what happens when that pressure begins to deviate? Well, W.S. Tyler has helped countless industries implement woven wire mesh for over 150 years, and is here to help grow your confidence in your mesh's ability to deliver accurate and repeatable results. So in this video, we'll go over the definition of woven wire pressure loads, what happens when there's too much pressure, what happens when there's not enough pressure, and how the pressure load can affect your operational expenses. Woven wire pressure loads are the forces that are placed on the mesh through external pressure. This pressure can come from mechanical forces, thermal forces, fluid flow, environmental loads, and thermal expansion. These pressure loads should play an integral role in the actual design of your woven wire. By taking these pressures into consideration, the odds are you'll have a more efficient woven wire experience. Placing too much pressure on your mesh can cause a handful of performance-hindering effects. First and foremost, excessive pressure can cause your mesh to deform. This deformation can suppress the performance of your mesh and cause excessive fatigue. And these extra pressure loads can also create breaks and faults throughout the weave. Creating more tears, breaks, and faults ultimately diminishes the longevity of the weave. Also, weld seams can become weakened under too much pressure, again creating breaks and faults alongside the seams. This all goes to say that placing too much pressure on your woven wire can create a slew of safety concerns, not to mention an increased amount of operation expenses with the increased number of repairs and replacements. Placing too little pressure can also create several operational problems. More specifically, the performance and durability of your mesh. For instance, not applying enough pressure can leave particles unable to pass through the mesh. This means there's an increased particle accumulation that can eventually lead to clogs. Not good. And on top of that, this accumulation will also increase its wear and tear. With a dip in woven wire performance and accelerated wear, the overall quality of the final product will most likely become compromised. So, like I said, too little system pressure can lead to clogs and material accumulation, which can cause permanent damage to the mesh, which means increased downtime for maintenance and replacement expenses. But on the other hand, placing too much pressure on your mesh can lead to deformation and broken wires, which means the money for replacement costs. Not only for your mesh, but any equipment that could be damaged from loose wire fragments. Now, when pressure loads are too low, production is subsequently slowed down. Naturally, this raises labor and energy costs. And not to mention, the reduction in product quality that comes with pressure load variations often leads to costly recalls and potential legal battles. Thanks so much for watching. If you have any questions, fill out a contact us form so we can answer your specific questions. Just click the link in the description. And if you have any more questions about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click that second link and you'll be that expert in no time. And don't forget to click that subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.